Welcome back, dear student. In last class, we have seen that what are our performance of our designed aircraft. First example was unmanned aircraft and second example was designed. And we have seen all the performance parameters, how the aircraft is performing at a different altitude and how the parameter is varying with velocity and what are the shear force, bending moment, Venn diagram, so many things we have covered. Now it's time to do the flight simulation. In flight simulation, whatever so far design we have done, we will see whether our craft is behaving well or not. So this is in this only I will show you the only flight simulation, but the theory behind this flight simulation and what are the things you need to study for a flight simulation, that I will offer a separate course called flight simulation in the future. In that we will be having the detailed lecture series, but here I will give you some idea. So in flight simulation you need to simulate the aircraft. Aircraft will fly in reality in the air, right? So with time the aircraft will reach from the one position to another position. So in this time domain, you have to check whether the aircraft is behaving well or not. So how will you check? By simulating the equations of motion. So consider this is an aircraft. This aircraft can rotate in three direction, pitch, roll and yaw, and can translate in three direction, x direction, y direction and z direction. The total 6 degree of freedom it has. So you can see aircraft can have a 6 degree of freedom, 3 translation motion and 3 rotational motion. Okay. So when you write, see, everything starts from the fundamental, right? So if you write F equal to ma, or in general you will write F equal to d by dt into mv. And let's say in aircraft case m is constant, you will write dv by dt. And this is F. This F can be the combination of aerodynamic force, gravitational force and propulsive force. Okay. And aircraft is moving in air. So if you define the body frame, see, positive y along the wingspan, positive x along the fuselage axis and positive z downward, right? So if you define this axis, but body is accelerating, so you cannot apply the Newton's law on an accelerating frame. You can apply the Newton's law in only two conditions: either it is moving with a constant velocity or it is a stationary. So what you can do? You can transform the body frame to inertia frame. Whatever so far motion you are having in a body frame, that you can transfer in the inertial frame, and then you can measure the thing. For example, like if any vector is rotating in a body frame, that can be written as a d by dt a, that can be the inertial frame. Okay, this is the inertial frame, and this dA by dt into dA by dt body frame plus omega is angular velocity into a. So if you add this extra component, you will get back to inertia frame. So when I will derive the equations of motion in a flight simulation course, that time I will do the details. Okay. When you do this, you will have a three forces, three moment equation. One force is Fx, Fy, Fz, and then this is rolling moment, pitching moment and yawing moment. So three force, three moment. So now you can write acceleration u dot w dot u dot acceleration u dot v dot w dot, and this p dot q dot and r dot. If you multiply this by m, you will get force, and if you multiply by this inertia, for example, like a roll x axis, y-axis and z-axis, you will get the moment. Okay, roughly pitching moment, rolling moment, pitching moment, and yawing moment. Okay, this PQR is a angular rates in body frame, and similarly PQR is an angular acceleration. Now, if you integrate you will get, if you integrate you will get u dot, you will get u. If you integrate u dot, you will get u. Similarly, if you integrate v dot, you will get v, w dot, w, and then pqr. And there is a relation between pqr and phi theta psi. Phi theta psi is an angular Euler angle. So, for example, when 3 successive rotation is given, 3, 2, 1. For example, yaw, pitch and roll. Then you will move from inertial frame to body frame. Okay. So, from this 3 rotation is called Euler angle, phi theta psi. Phi theta psi. Okay. So, clearly you can see that phi dot will not be equal to P, theta dot equal to not equal to Q, and psi dot will not be equal to R. There will be a rotation matrix. That rotation matrix I will also discuss in the flight simulation course. So, now if you integrate phi dot, theta dot, psi dot, you will get the attitude of the aircraft. So, integrating u dot, v dot, w, you will get uvw, and if you transform from body to inertial using direction quotient matrix, you can actually get the x dot, y dot, z dot, and if you integrate x dot, y dot, z dot, you will get the actual position of the aircraft. Do not worry, we will discuss everything in a flight simulation course. So, now you will be having uvw, pqr, phi theta psi, and xyz. So, there is a 12 states. These are called aircraft states. So, with the time you have to see how my aircraft is behaving, where it is going. So, this from this 12 states actually you can check. Okay. So, the purpose is, and you can actually write the equation of motion in any framework. For example, I have written in MATLAB. You can integrate, okay, and you can check whether your aircraft is behaving well or not. And here you will give some input. So, that means here you are checking the natural response of the aircraft, not force response. In autopilot course, I will cover the force response, where you will use the autopilot in order to navigate from one position to another position. But in order to check, okay, integration you can do, but for integration you need some initial condition, right? So, here in the initial condition is trim. Here initial condition called trim. So, in trim, that it means equilibrium. So, you have to trim the aircraft and give us an initial condition, and you have to check how your aircraft is behaving. In this lecture, what we have done, we have trimmed the aircraft at a 5 km, and we will check how the aircraft is behaving, and what are the math behind it, science behind it, that I will cover in the flight simulation course in the future. You can see here I have written my equations of motion in this block. This block required aerodynamic data that in last class we have constructed the flight aerodynamic model. Longitudinal, rudder, design parameter, everything you have to enter. Atmospheric model also we have done model, right? That also you have to provide what altitude, what condition you are flying. This controls you have to, initial controls at a trim you have to supply. Okay. For example, let's say aircraft is flying at a steady state level flight with a 14 meter per second, or for example in this UAV what we will consider is a 14 meter per second at the sea level, but 17 meter per second at a 5 kilometer. Now we will simulate at the 5 kilometer. It's flying 17. What is the elevator required? That you have to give. That is nothing but the trim elevator. Okay. And now with the time we have to simulate. This is a extra block I have designed for input design. That means you have to check roll mode, spiral mode. That also I will cover in the flight simulation course. Okay. So now this is the integration block. Equation of motion is written here. Here I am integrating the same, and now if I run the simulation, you will see the simulation is running in real time. You can see my trim angle of attack was around 6 degree, and with the time aircraft is attaining the 6 degree only. Here you can see 6.03, 6.08, almost negligible. Only aircraft is flying at a 6 degree angle of attack. Okay, if you increase the scale, you will see this is a straight line only, nothing changing. Okay, so that means whatever so far I have selected as a trim condition, aircraft is perfectly flying. But this is the angle of attack. We have to check other parameter also, whether it is flying on perfectly or not. Okay. Likewise, you can see altitude. You can see we have to check. Even aircraft can at an angle of attack 6 degree, but it can drop. Altitude can drop, right? So we have to show that it is a steady state level flight. Altitude is not changing. So you can see that I have started with the 5 kilometer, right? And now nothing changes, right? 4999.75. That means 5 kilometer only, right? This time. Now if we see this velocity, what I said? 17 meter per second. No? See, 17 meter per second or approximately 17.8, 17.9. So we can consider say 18 meter per second, and now it is perfectly flying with that velocity, right? Okay. And since we have disturbed in longitudinal plane, so the aircraft will not have any. I will run again. Aircraft will not have any disturbance in other two axes. For example, if I check roll is 0. You can see roll is 0, right? Roll is 0. Aircraft is not rolling. Aircraft is having motion in this plane only. No roll, right? Similarly, you will check the yaw. And what is the integration of P dot? Is P an integration of phi dot? Is phi bank angle? You can see bank angle is also 0. And this is what other parameter you can see? You can check psi also. Psi is also 0, but it can 45 degree also. For example, let's say I am moving along the north. Okay, I am going in the north direction only. But if I trim in the north or 45 degree from the north, it will go in the 45 degree. So this is not, if it is non-zero, do not think it is not a trim condition. It is trim only. It is a heading angle. You can trim in this direction also, in this direction, that direction, doesn't matter, right? And you can see aircraft is not yawing also. This is a yaw rate, no yaw, right? Because no lateral and directional motion were introduced. Okay. Now you can see the pitch rate also. Pitch rate also. That means initially aircraft is having, when you disturb, it has some pitch rate, and finally, ultimately, it will go to the 0, right? And you can see from aircraft, when you give the trim condition, aircraft is taking some time. But what I said in dynamic stability, it will take time to damp out. Okay. So similarly, it is happening here. And see the y-axis amplitude is very less. This is a degree per second. 0.05 degree, 0.1 degree, minus 0.1 degree is almost 0 only, right? So this all about the flight simulation. So but these are the graph only, like for example how aircraft naturally is behaving. Okay. But in the next class I will show you with the visual how the aircraft is moving in a space, how the aircraft is behaving in a space. Your plant and your controller will be running in the MATLAB, and your trajectory and position data and attitude data, that means you can set trajectory data, will be displayed in the X-plane or flight gear. I am using both, but I will show you with the X-plane. So here I am using X-plane as a just for visual, like here I am sharing my knowledge through the blackboard, similar to that. Okay. So we'll meet in the next class. In next class I will teach you the visualization, and thank you very much. And remember, here unmanned aircraft, UAV, we have simulated. Like that you can simulate the manned aircraft also, which we have designed. And in simulator I will show you the manned aircraft, okay, which we have designed 5-seater, right? So thank you so much. We will meet in the next class. Thank you.